problems. First, find the Z transform find the Z transforms of the following. Here, first one, e to the power of minus an, e to the power of minus an. Second one, e to the power of minus an into n. Next one means C. So e to the power of minus an into n square. So solution. So here, what is e to the power of an? So I will take here first one. Let here un equals e to the power of minus an. So I will write this one can be written as un equals e to the power of minus an into n. I will take. So un equals, here I will take this one as k to the power of n, where k equals e to the power of minus a. So here this becomes e to the power of u suffix n equals k to the power of n. Now apply Z transform. So Z transform of un equals Z transform of k to the power of n. So what is k to the power of n formula? Z transform of k to the power of n, we know that z divided by z minus k. So what is un? Here you taken un as e to the power of minus an. So Z transform of e to the power of minus an equals, what is k here? K is also e to the power of minus a. Substitute that one. So z divided by z minus e to the power of minus a. So this is the required result. Now second one, what do you have? E to the power of minus an into n. So let un equals e to the power of minus an into n I will take. So this can be written as e to the power of minus a into all to the power of n into n. So I will take this one as k to the power of n into n, where k equals e to the power of minus a. So this is your un. So apply Z transform. Z transform of un equals Z transform of k to the power of n into n. So what is Z transform of k to the power of n into n? It is, what do you get? Z transform of un equals, what do you have? Z here, kz divided by k minus z whole square. So what is k here? K is e to the power of minus a, and what is un? It is e to the power of minus a into n. So substitute this. So Z transform of e to the power of minus an into n equals, here what is k? E to the power of minus a into z divided by z minus e to the power of minus a whole square. So this is the required solution. Now see, so what is here? That is e to the power of minus an into n square. So let un equals e to the power of minus an into n square. So I will take this one as k to the power of n into n square, where k equals e to the power of minus a. I will write same as it is I wrote here. So now apply the Z transform. Z transform of un equals z transform of k to the power of n into n square. So what is k to the power of n into n square here? Z transform, so z square divided by here, sorry, what do you get? K to the power of n into n square is k times of z square plus k square into z whole divided by z minus k whole cube. So this is your z transform of un. So what is un? Un means here e to the power of, substitute that one, e to the power of minus an into n square equals, what is k you taken? E to the power of minus a. So substitute that one, e to the power of minus a into z square plus e to the power of minus a whole square into z whole divided by z minus e to the power of minus a whole cube. So this is the required solution. So next one, find the z transform, find the z transform of n plus 1 whole square, n plus 1 whole square. Solution: let un equals n plus 1 whole square. So n plus 1 whole square means what do you get? A plus b whole square formula. Apply a plus b whole square, z to the power here zn, sorry, u sub x n equals here n square plus 2n plus 1, a plus b whole square. So now apply z transform. Z transform of un equals z transform of n square plus 2 z transform of 2n plus z transform of 1. So z transform of what is un? It is n plus 1 whole square equals, what is here? Z transform of n square. Here 2 is constant, so take it outside. So z transform of n will get plus z transform of 1. Now z transform of n plus 1 whole square equals, what is z transform of n square formula? It is z square plus z divided by z minus 1 whole cube plus 2 into z transform of n. Z transform of n means z divided by z minus 1 whole square, and plus what is z transform of 1? Z transform of 1 is z divided by z minus 1. So this is the required solution. If you want, you can simplify this one also. And here next one, obtain the z transform, obtain the z transform of cos n theta and sin n theta. Hence deduce z transform, hence deduce z transforms of the following, here first one, k to the power of n into cos n theta. Second one, k to the power of n into sin n theta. Next one, third one, e to the power of minus an into cos n theta. fourth one here e to the power of minus an into sin n theta. So remember this one, what you have obtained the Z transform of cos n theta and sin n theta, hence deduce that Z transform of the following. First one, k to the power of n into cos n theta, k to the power of n into sin n theta, e to the power of minus n into cos n theta, e to the power of minus n into sin n theta. So first you have to find out cos n theta and sin n theta. Z transform of cos n theta and sin n theta you have to find out. So solution, here directly you can't find out for Z transform of cos n theta and sin n theta. So first you have to find out the solution for Z cos n theta and sin n theta. So how will you get? We know that e to the power of I n theta equals cos n theta plus I sin n theta, right? So now this can be written as e to the power of I theta whole to the power of n whole to the power of n. So this can be written as k to the power of n, where here this can be written as like this. So this is theta. So what do you get? Where k equals e to the power of I theta. So now apply the Z transform. So Z transform of I will take this one as e to the power of I n theta, e to the power of I n theta equals, what do you have? Z transform of k to the power of n, k to the power of n. So what do you get here? Z transform of, what do you get? E to the power of I n theta equals, what is Z transform of k to the power of n? Here Z transform of k to the power of n is z divided by z minus k. What is k? K is e to the power of I theta. So Z transform of e to the power of I n theta equals z divided by z minus e to the power of I theta. So we know that what is e to the power of I n theta? Cos n theta sin I into sin n theta, right? So what is e to the power of I theta? Here e to the power of I theta equals cos theta plus I sin theta will get. Remember this one. So now here if you substitute here directly, you can't simplify this one. First multiply and divide by z plus e to the power of rationalize this one. So what do you get? Z minus e to the power of minus I theta divided by z minus e to the power of minus I theta. So this becomes z into z minus e to the power of minus I theta divided by z minus e to the power of I theta into z minus e to the power of minus I theta will get. So simplify that one. So what do you get? Z square minus z into e to the power of minus I theta divided by what do you get here? Z here if you simplify this one, z square minus z into what do you get? E to the power of I theta plus e to the power of minus I theta plus e to the power of I theta into e to the power of minus I theta, you will get 1, because here e to the power of I theta into e to the power of minus I theta. So this can be written as 1 over e to the power of I theta. These two will get cancelled, so we will get 1. So I wrote here. So what do you get now? Here this is z transform of e to the power of in theta. In theta. So what do you get here? Z square minus z into e to the power of I theta can be written as cos theta plus I minus I sin theta whole divided by what do you get? Z square minus here e to the power of I theta can be written as cos theta plus I sin theta, and here e to the power of minus I theta can be written as cos theta minus I sin theta. So if you add these two, you will get these two get cancelled, you get 2 cos theta. So I will write directly 2z into cos theta. This can be written as, and here plus 1. Now here simplify this one. What do you get? If you multiply with z, here z square minus z into cos theta minus into minus plus I into z into sin theta whole divided by z square minus 2z plus cos theta plus 1. Cos theta plus 1. Now what do you get here? What is e to the power of in theta? E to the power of in theta is here z transform of cos n theta plus I sin n theta equals, what do you get here? Z square here z square into, here I'll take real parts one side and imaginary parts one side. So z square minus z into cos theta divided by separately here, and what do you get? Plus I into z into sin theta whole divided by, what do you get? Z square minus 2z this is into cos theta plus 1. Now here what do you get? This can be written as z transform of cos n theta plus I into z transform of sin n theta equals, here also real and imaginary parts divide, here separate this one. So what do you get? Cos theta whole divided by z square minus 2z cos theta plus 1 plus I times of z into sin theta divided by z square minus 2z into cos theta plus 1. So separate real and imaginary parts is also over. Now compare this one. So what do you get? Z transform of cos n theta. Therefore what do you get? Z transform of cos n theta is this one. So what do you get? Z square minus z into cos theta divided by z square minus 2z cos theta plus 1. And here z transform of, here imaginary parts you have to compare. So what do you get? Sin n theta, your answer is z into sin theta divided by z square minus 2z cos theta plus 1. So this is the required solutions. This is the required solution. Now what do you have to find out next here? Next you have to find out here k to the power of n into cos n theta. Cos n theta. First one, k to the power of n into cos n theta. Now we have to use the damping rule property. So what do you get damping rule property here? By damping rule, so what do you get? Z transform of k to the power of n into cos n theta. Here that means Z transform of k to the power of n into un. So what do you get? This becomes u bar of z by k. Wherever z you will get, you have to replace z by k. So remember that one. So what do you get now? Here un equals k to the power of n into cos n theta. So z transform of un equals z transform of k to the power of n into cos n theta. So here this can be written as, here what do you get? Cos n theta. Here what do you get? Cos n theta. You have cos n theta, right? Here you have to replace, wherever z is there, wherever z is there, you have to replace z by k. You have to replace z by k. So what you get now here? Z by k whole square minus z by k into cos theta whole divided by, here z by k whole square minus 2 into z by k into cos theta plus 1. Cos theta plus 1. Now if you take LCM, you will get the answer is Z transform. What is un? Un is you taken k to the power of n into cos n theta. So k to the power of n into cos n theta equals what do you get? I'll write final answer here, z into z minus cos theta, k times of cos theta whole divided by, you will get k square minus 2kz cos theta plus k square. Take it k LCM, so we will get the final result. Now second one, so what do you get? K to the power of minus n, k to the power of n into, you will get sin n theta. So here also you have to apply damping rule property. So what do you get here? By damping rule, z transform of k to the power of n into sin n theta equals u bar of z by k. So you know z transform of sin n theta. So wherever z transform of sin n theta, wherever you have z here, so you have to replace z by k. First ನೀವು z transform of sin n theta ಕಂಡುಹಿಡಿಯಬೇಕು. ಇದು ಬಂದಿರೋ ಆನ್ಸರ್ಸ್ಗೆ ಝಡ್ಗೆ z by k ನ ರೀಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ದಟ್ಸ್ ಆಲ್. ಸೊ what do you get here? Z transform of, here I will take this one as un equals k to the power of n into sin n theta. So Z transform of un equals Z transform of k to the power of n into sin n theta. So what is Z transform of un? You have to find out k to the power of n into sin n theta equals, here what is here? Sin n theta ಗೊತ್ತು. So sin n theta ಗೆ replace k by z. You have to replace, wherever z is there, you have to replace z by k. So what do you get? Z by k into sin theta whole divided by z by k whole square minus 2z by k cos theta plus 1. So you'll get, if you simplify, you'll get final answer is, so you'll get k times of z into sin theta divided by, here you will get z square minus 2kz cos theta plus z square. So this is the required solution. So next, take it next to as homework. Which one is homework? Here you have e to the power of minus an into cos n theta, and fourth one e to the power of minus an into sin n theta. So this can, here I'll give hint here, e to the power of minus a into whole to the power of n into cos n theta you can write. So this can be written as k to the power of n into cos n theta. So you can apply z transform. So same as it is, you'll get here also e to the power of minus a into whole to the power of n into sin n theta you can write. So this can be written as k to the power of n into sin n theta. So remember that one. So substitute that one, k to the power of n into sin n theta, you will get the required solution.